Hi friends, this is Gautam. In this video tutorial, I am going to discuss about window size scaling. So before discussing this topic, first of all we should know about the flow control. So I am not making any slide for this concept. So instead of that, I will show it in real time. So before recording this video, I downloaded one image from the web server. So the image size is 22 KB. So during the downloading that image, I will capture that file in Wireshark. So that file is this Wireshark. So I will show it in Wireshark. So how the window size is working and everything. So before that, flow control. For an example, from server to client we are sending some data, so we can use some TCP protocol. For an example, you can take it as an HTTP protocol. It comes under TCP. So now client is requesting some data from the web server. So for an example, the data size is 500 MB or something like that. So now server have Wi-Fi configuration. They have Wi-Fi configuration like the data transmission rate and everything should be high. But in client we don't know. It depends upon the client machine. So some of them are downloading that file from mobile. Some of them are downloading that file from computer. Some of them are downloading from computer with Wi-Fi configuration. But normally in server, definitely we can use Wi-Fi configuration because server will respond to multiple client requests. So for an example, if the server is capable of sending, for an example, sending 1 MB of data per segment, for an example, but client can able to receive only 200 KB of data in receiving buffer means. So that time definitely the server will overburden the client machine. So to avoid this one, we can use flow control. So flow control means before, during three-way handshake, so the window size should be there. So window size indicates the receive buffer size. For an example, during the three-way handshake itself, server will send the window size of some value. So the window size value in bytes. So that means, for an example, 500 bytes means if the sender will send 500 bytes means it indicates I can able to receive maximum 500 bytes only. Same like server. So server will send their buffer size during three-way handshake. So for an example, client send the window size as 500 KB, sorry, 500 bytes. So that means I can able to receive maximum 500 bytes of data. So it will send to the server. So server, they will send the data 500 segments. So 500 bytes in segment. So once they will send 500 bytes of data to the client, then he will wait for an acknowledgement from the client. So once the client send an acknowledgement, then the server will send next to 500 bytes of data. So that is the window size. It will indicates the buffer size. So I will show it in real time. So this is the three-way handshake. So I already told you I download one image from the web server. So HTTP comes under TCP protocol. So the first of all is a three-way handshake. So three-way handshake. So first of all, 192.168.1.140 is my client PCIP and 174.143.213.184 is a server IP. Okay, so first of all the client will send the signorized packet. So in that packet the sequence number, so the sequence number is any random number is a 32-bit value, but in Wireshark they will use relative sequence number. So relative sequence number means it will start from 0, but in production it will be randomly generated. Okay, 0. Next one, window. This window indicates the client capacity for receiving their buffer size is 5840 bytes. So length equal to 0 means in TCP segment how much of data we are sending. So now three-way handshake we are not sending any data, so that's why the length equal to 0. Next one, MSS, maximum segment size. So this will indicate the data. So here we can see maximum segment size is 1460. So as per layer 2, in layer 2 interface, in physical interface, the maximum transmission unit is 1500 bytes. So in 1500 bytes, so IP version for header is 20 bytes and TCP header is 20 bytes. So you can minus 40 bytes. So you will maximum send the data at single segment is 1460 bytes. Next one, yes, so just I open this one and I will explain you. So this one is a flag is sync flag. So this all the things you know already. I will explain in the TCP header as well as the three-way how the TCP process will start and terminate the session. I will put separate video. So just go through that video once again. Okay, so here option. So in option field, we can see yes, permitted. So yes, means selective acknowledgement. So what is meaning by selective acknowledgement? So for an example, if the client requesting some data to the server, so the server send all the data to the client. So consider like 10 segments. So each segment it will send 100 bytes, something like that. The data is sent to the client. For an example, I'm saying. So now the client receiving the segments. So the server will send the 10 segment to the client. So in the 10 segment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in that fourth segment I lost, seventh segment I lost. So the client will send this selective acknowledgement to the server, the fourth segment and seventh segment I lost. So the server they will send only fourth segment as well as the seventh segment. So that's why we can use selective acknowledgement. So this everything will during three-way handshake itself they will mention in the three-way handshake itself. In case if the selective acknowledgement is not permitted means, so that time the server will send from the segment 4 to 10 once again, but the client lost only 4 and 7. So for that reason only we can use selective acknowledgement. So next one, window size. In TCP header, the window size field is 16 bits. So 2 power 16 you will get 65,535. So that means 65,000 means we can maximum we will send only 64 KB of data per segment. So this was developed in 1985-80 at that range. So that time we are using serial cable only. So the speed of the serial cable is 64 KB. So now RFC 1323 standard. So they are going to use calculated window size. So what is meant by calculated window size? So nowadays we are using gigabit Ethernet 10 gig. So 10 gig, 40 gig. So likewise we are using the port speed capacities like that. So what we are going to do means instead of window size we have to increase that one. So for that reason RFC 1323. So in TCP header here we can see. So in TCP header we have optional data. So the optional data is 0 to 40 bytes. So from the 0 to 40 bytes we can use 3 bytes used for scaling factor. So using this scaling factor we can increase our throughput rate. So more data transfer rate. So for that reason we can use this optional data. From that optional data we can use 3 bytes of data for scaling. So window scaling, so I will show it to you. So here we can see the window size. So window size is 5840. The client sent to the server. So that time they mentioned the window size as 5840 bytes to my receiving buffer capacity. So here calculated window size. So the calculated window size I will tell you in next packet. So in during the three-way handshake itself, they will mention that selective acknowledgement and as well as the maximum segment size. So maximum segment size means per segment how much of data maximum we can transfer and receive. So both client and sender they will during the three-way handshake itself they will mention the maximum segment size. So which one is the lowest one, that one will be agree for both client and server. So here the client will be sending the maximum segment size as 1460. Okay, here we can see window scale in TCP option window scale. So in window scale, so nearly 24 bits are used from the optional data, that is 3 bytes. So client they are using 7 bits. So 2 power 7 they are using 128 multiplied by 128. So I will show it to you in next packet, so you will understand what I'm saying. Okay, so this is a three-way handshake. The client will send to server. So one more thing, in Wireshark, this length indicates the total size of that entire packet. Layer 2, layer 3, layer 4, complete entire packet size is this one. And in this length field indicates during the TCP segment how much of data they are going to send. This length indicates. Okay, now client send the synchronized packet to server. Next, the server will acknowledge that synchronized packet and sending their synchronized. So here we can see sequence number is 0 and acknowledgement is 1. So they receive the sequence number and sending acknowledged number as 1. So now server indicates the window size as 5792 and length is 0. I just click this packet. So here we can see server also indicates the maximum segment size as 1460 and also selective acknowledgement is permitted and TCP window scaling. So window scaling server is using by 64, so we can use 24 bits from optional data. So client they are using 128 bit, 7 bits they are using, so 2 power 7 128, so the multiplier of 128, and here they are using 3 bit, sorry 6 bit, 2 power 6 they are using multiply by 64 bit. So this window size and everything, window scaling, everything is based upon that sender and receiver OS. So how much traffic flow, bandwidth, and network interface card speed, latency, so everything. So based upon that, these values are dynamically changing. This is not a fixed value. Okay, so the final acknowledgement coming from the client. So here we can see sequence number 1, acknowledgement 1. So this final acknowledgement from the client. So this is the window size fixed for the client. I can able to receive up to 5888 bytes. So they are informing to the server. So now server will send the data in during the segment. They will send up to 5888 bytes of data. So once they completely send it, then the server won't send any data to client until the acknowledgement come from the client. Once acknowledgement came, then next set of data they will send. So likewise the window size meaning. Okay, so now three-way handshake is completed. Next one, fourth packet. Now the client requesting that image from the web server. So that's why it's a HTTP and get image. Okay, so the length is 200. So now this is a server IP 174.143.213.184 is a server IP and this is a client IP. Now the server is acknowledging to the client, I got your request. So here we can see, just open this request. In that request the data size is, so the TCP segment length, so the data size is 134. So the server is acknowledging 135. So I got your web request. So that's why they're sending the acknowledgement as 135 and sequence number is 1. Okay. Next to one, window size. So the server window size is 6912 bytes. Okay. Now the server will send the data to client. So the total length here is 1514. So here 1514, from that they will send the data as only 1448 bytes of data they are sending. So here this length indicates the during this segment they are sending 1448 bytes of data they are sending. So total capacity is 1154. So from there layer 2 Ethernet header is 14 bytes. Next one IP version for header is 20 bytes and TCP header minimum value is 20, but in this packet they are using 32 bytes. So here we can see 32 bytes of header. So using calc we can calculate that one. So 14 bytes for Ethernet header plus 20 bytes for IP version for header plus 32 bytes for, so total is 66. So 66 minus 1154, we will get the data 1140 1448. Okay, so here we can see window size, calculated window size, and window size scaling factor. So during three-way handshake itself, both client and server, they will mention the scaling factor, window scaling factor. So window size is 16-bit field. If you are giving 2 power 16, you will get maximum per segment we can transfer only 64 KB. So in earlier stage they develop like that. So for that reason only, in nowadays we are using gigabyte 10 gig. So likewise we are using advanced technology, so advanced port speed. So for that reason they have to increase the throughput and increase the data transfer rate during the TCP session. So for that reason they are using Windows scaling factor. So from the TCP header, from optional data, so there is 40 bytes are there. From there 24 bits are they are using for Windows scaling factor. So during three-way handshake itself, how many bytes they are using? So client they are saying 7 bits. So 2 power 7 128 multiplier, and server sends 64 6 bits. 2 power 6 bits means 64 bit multiplier. So now the window size scaling factor is 64 and window size value is 108. So 108 into 64, the calculated window size is 6912. This calculated window size is the true value of the server receive buffer. So 108 into 64, we will get this value. So the TCP payload is this much of data we are sending to the client. Okay, so next one, the client. So now the client will acknowledging the packet from the client, they will send to the server. So this the client send the sequence number 135, and so here sequence number, so the sequence number is the how much of data is transferring during the TCP session. So previously, so the server will start with sequence number 1. So previously they will use the sequence number 1. So we can click that sequence number once again. Okay, so in sequence number itself, here we can see 1 and next sequence number. Okay, so sequence number means is a 32-bit field. So during three-way, so during the TCP transmission, so uh, during TCP session, so how much of data is transferring? So we can calculate. So using TCP segment, we can check that one, how much of data is transmitted during the TCP session. So here we can see now the sequence number is 1. So after three-way handshake, the server don't send any data to client. So the sequence number is 1. Next sequence number, here we can see 1449. So that means this segment they are sending sequence number 1 and they will send the data as 1448 bytes. So this sequence number plus how much of data they are sending, so the sequence number plus how much of data they are sending this segment, it will be the next sequence number. So here we comes to here, the TCP payload is a data 1448 bytes of data they're going to send. So sequence number is 1 plus this data, so that is next sequence number is 1449. Okay, so here the client sending the sequence number as 135. That means here the client send a request, so the data is 135. So that is the sequence number for here. So using the sequence number 135 and acknowledgement, so I will receive 1448 bytes of data from server. So that's why they are sending acknowledgement 1449. That means I will receive 1448 bytes of data. So next one, here we can see window size 8832. So the previously the final, during the final acknowledgement, they're saying window size is 5888. Now the window size is 8832. So the window size, it will be changing dynamically. So based upon that client, in client machine, how many TCP sessions are running, so depends upon that OS and network interface card speed, that is NIC card speed, bandwidth, latency. So based upon that, the window size, buffer size will be dynamically changing. So it will be increasing, it will be decreasing, so based upon how many TCP session is operating on the client machine. Same like server also. Maximum in server, the window size value, the window size means the receive buffer size will be minimum only, because server not getting anything from client, so client only receiving data from the server, so they will increase the window size. So here they increase the window size as 8832. So length equal to 0 means the server sends only acknowledgement. So that's why there is no data in that segment. So they send 0. Okay. So next one, here we can see this packet server will send the data to the client. So the sequence number is 1449. So previously I showed you sequence number 1 plus this data. So 1 plus 1448 is the next sequence number 1449. So here click this client. So client, they are using the sequence number as, they're using the window scaling factor as 128. Here we can see the window size scaling factor is 128. So window size into this scaling factor, we will get 8832. So normally we are downloading 22 KB of data, so it will comes under that range only. 2 power 16 means we are using 65,535 bytes of data, so that means 65 KB. So in case if you are downloading more than that one, so that time the scaling factor will be very helpful. So 69 into 138, 128, it will getting 8832 bytes. So the calculated window size is the true value, receive buffer size. Okay, so next to segment, they are sending the data. So now the sequence number is, they're sending the acknowledgement, so they're waiting for next set of data 1449. So now the sequence number they are sending 1449. Now they are sending the data or 1448. So now 1449 plus this data, it will be next sequence number for server, the sending to client. Here we can see 2897. Okay, now again the client will sending an acknowledgement for this segment. The sequence number is 135. Why the client is using same sequence number means they are not sending any data. If they are sending any data means, so the current sequence number plus how much of data they are sending, you can add the sequence number plus data, it will be a next sequence number for client, but client is not sending any data, so that's why the sequence number is fixed 135. So they are sending acknowledgement, I got received 2896 bytes I received. So they are sending 2897 means 2896 bytes I received, meaning. So the window size, here we can see now the client increasing level 1648. So next segment they are sending 2897, 1449 plus this data, you can add, you will get 2897. This is a sequence number, and again they will send 1448. So maximum we can send 1448. So maximum 1514 byte. So from that 14 byte for Ethernet header, 20 bytes for IP version 4 header, and 32 bytes for TCP header. So rest of the data is 1448. So here we can see. So now 2897 plus 1448 will be next sequence number 4345. So they are sending acknowledgement. Here we can see I received 4034. So likewise each and every packet they are sending an acknowledgement. So here the server point of view, is different and client point of view is different. So Windows says, I already told you how much of the size of the buffer size. For example, if client send the final acknowledgement, they mention the window size. So window size indicates you can send this much of data. After sending this data, so the server will expect the acknowledgement from the client. If they are not getting any acknowledgement, they won't send further data. They will resend that same data only. So they have to wait for acknowledgement. Once they got acknowledgement, then only they will send the data to the client. So come below. So this one is an window size 1448. So this one 6666 indicates the acknowledgement from the client to the server. So the window size is changing dynamically, so based upon that client, how many TCP operation they're performing. If the CPU is in ideal means, they will increase the window size. So likewise. Okay, so this is the final packet. You can click here. So here we can see the total is, so totally 16 segments they are sended. So total capacity is 22,045 bytes. So that is 22.045 KB. So each and every packet they are sending maximum data 1448 bytes. Here we can see 1448 bytes. So the final packet is 325 bytes. So finally I downloaded that image. So after completing this one, I'm going to terminate this session. So here we can see four-way handshake. So finally, the client will send the final acknowledgement to 22,045 I received. So 22,046 they're sending for acknowledgement. Now the window size is 52,224. So the client said the sequence number is same only because the client not sending any data. They are receiving data from the web server. So after receiving the data, they are going to terminate this session. So they are using FIN-UCK. They are sending acknowledgement again. FIN-UCK from the server side, and client will acknowledge. Now the session will be terminated. Okay friends, so the same Wireshark file I will mention in the comment section. Just download it and go through this file so you can able to understand what I'm saying. And one more thing, I will mention that RFC link 1323. So RFC means request for comments is like a standard. So as per the RFC 1323, so we are using scaling factor. So we can use 24 bits from the optional data. So during three-way handshake, itself, they will mention the maximum segment size and scaling factor, because if there is no three-way handshake means it's too difficult. How much of scaling factor they are using is too difficult to find out. So during three-way handshake, before connection establishment itself, they will mention the scaling factor as well as the selective acknowledgement. Everything they mention in the three-way handshake. Then afterwards they started transferring the data. Okay friends, I hope you can understand this concept. If you have any queries, please ping me in the below comment section. I will reply answer to your question. Thank you. Thank you for watching my video and subscribe my channel for further updates. Thank you friends.